So yeah, what is data warehouse? So yeah, data warehousing is like this concept's been there like since last 60, 70 years. Like we are been doing this data warehousing, right? So what exactly is data warehousing? So yeah, guys, sorry, this is theoretical. I have to go through all this slides. Sorry if I anyone get bored on that. So data warehousing is a type of data management system that is designed to enable and support business BI activities, especially analytics. So all the companies will do this reporting and analytics, right? Now with the increase in this data science, like all the companies are building their data science teams. Now building data science models and exploring the data and getting insights out of raw data and all. So what is the foundation for creating reports, or like if I want to build some database model, what is something we need? We need data warehouse, right? So without data warehouse we cannot do reporting, and again it is difficult to build a data science model. So what exactly we'll do in data warehousing? Data warehouse centralize and collects large amount of data from multiple sources. So for example, if your company using different products like SAP, Salesforce, Microsoft server like Oracle, you have like different data sources. So in data warehousing, we'll extract the data from different sources and we'll put into we'll consolidate the data and we'll upload into the different database. That's called data warehouse. So usually data warehousing serves as a historical. Suppose down the line, so I'm running the business like since let's say last 20 years. I want to find out what is my sales comparing to last 10 years. So historical data, all the historical data will be available in data warehouse. So it serves as a single source of truth for the historical data. If companies wants to refer, like if I want to do a comparison between last 2 years sales versus this year's sale, I need historical data, right? The historical data will be available uh, in data warehouse. So let's see one small example just to understand this part. Let's say there is a one mobile company, Verizon or Geo. So they are selling like mobile phones, and also like they are selling. I'm talking about stores, not about network. Let's say this Geo and Verizon. Verizon is US based and Geo is India, right? So they are selling mobile phones in their stores. So they have this point of sale software, POS. For example, if they are selling any phone, then those transactions are getting recorded in MySQL. Okay, you can see the store name, customer name, and what device they are selling, and the device price, and when is the sales date, at what date the sale happened. So this is a transactional database. We are not talking about data warehousing or OLAP. This is OLTP completely. So any transactions happen, these transactions are recorded in MySQL. So the same store also selling insurance. So in US, if they are purchasing any phone, they'll do insurance. So insurance software is different here. Like they are using Oracle. So any transactions, let's say that I bought iPhone 11 and I wanted 2 years device. Protection, like screen protection or something. If I purchase that insurance, they are entering all the details here in the different software, and in the backend, the data is getting saved in Oracle. So here we have two transactional databases, MySQL and Oracle. And also in the store, let's say the stores are conducting customer satisfaction survey. So they're giving these papers and they're asking to fill whether they're happy or like not happy. So the data comes in different forms and different shapes. This is like unstructured data, right? Whereas this is transaction structured data, relational data. So we have the data coming in different forms. So now, if I want to if I want to build a data warehouse to answer this question, so our management wants to know this which store is performing best in terms of device and insurance sales total. So now the management they want to find out. So they have like several stores across different parts of world, India, US, and all. So they want to find out which store is performing best in terms of mobile sales and also the insurance sales. So in terms of customer satisfaction, which store and employee ranks the best? So we are collecting the data, right, in the form of unstructured data. Now they want to find out in terms of customer satisfaction, which employee ranks the best. So holiday season is coming. Which region is going to have the max traffic of customers? Just to predict the traffic in the stores. So we have the data. So in order to answer these questions, where is the data? The data is scattered, right, across different applications, different databases. We have like two databases, and again, we have the data in the scan form PDFs. So the data is scattered. So it is very difficult, right? Day to day, if I have to answer, like again, I have to, go to this software, extract the data. It will be difficult. So in the data warehousing, what we'll do is, if this is the business case and this is the data sources and all. So let's see how we will build the data warehouse and all. So you can see here, yeah, we already discussed like insurance sales and mobile sales. Both are like in the left hand side POS sale, we have the mobile sales details, and right hand side we can see insurance sales are there. Now we have to do the aggregation, right? So because the data is in two different sources, we have to extract the data. So ETL, right? Extract, transform, and load. We for the first step is extraction of the data. So typical data warehouse often includes following elements: and extraction, loading, and transforming. So we'll use different tools. Organizations will use different tools like Informatica, Talent, right? Informatica Power Center, if you heard about. So all these are ETL tools. We'll use those ETL tools to extract the data from these systems. So once the data is extracted, then we'll do the aggregation. So this is transformation. So once the data is extracted, then it has to be transformed. Right? What we are doing is we are bringing up like both mobile sales and also insurance sales, so that we are aggregating it by store. We have two stores here. If you see the store name, one is in New York and one is in Bangalore. So we are aggregating the sales amount. Then if you see, there is a problem with this, right? Because if you see, New York is like in US, and the sales is in the form of dollars, right? $1,100, 850, and but this store is in India, and yeah, you can see 80,000. So this is not good. I mean, this is not the correct form where we can do analytics. So if I want like what is the sales performing more, if I go with numbers, then India will come first, right? 80,000, because 80,000 is larger than $2,000, right? This comes first. So then we have to do the normalization. So normalization, you can see I have to convert this INR to USD, then it will be like apple to apple comparison. Otherwise, the comparison will go wrong. So once it is normalized, you can see now the 80,000 rupees is converted to dollars. Then this is the amount if I after converting. Then after doing all this, finally the result of this all the activity will go into, we have to store in data warehouse. So this is where Snowflake, Redshift, all the OLAP databases will come into picture. Google BigQuery, Redshift, Snowflake. So finally the data goes here. So the data science team, data analytics teams, they'll use Snowflake, and they'll create all their reports and dashboards and reports. So this is the life cycle of data warehousing. So this process of extracting the data, like I said, like ETL, we are extracting the data from all these sources. Finally, we are loading into data warehouse. So the left-hand systems, these are called OLTP. So OLTP, these systems are meant for high writes. So day to day, like if you go to bank or like ATM, like credit card, so these are all transactions, right? So these systems are meant for high writes. That means, for example, if there are two systems, OLAP and OLTP. For a minute, let's say to this system, to this database, you can insert like 1,000 rows. But in OLAP, I can maybe insert only 200 rows, because these are meant for high reads, not writes. So when I'm sending the data to database, these systems are meant for writing the data. That means if you do any transactions, immediately the transactions will get recorded in the database, right? Sometimes like banks will be down, like banking softwares, or like sometimes the systems are down. So like if this system is down, then the transactions won't be recorded. But these are not meant for analyticals. So if you do, these systems are not meant for reading. For example, if you want to answer these questions using the directly on OLTP systems, these are not good for reading the data. That means it will take a lot of time to query like 1 GB of data. For example, maybe if you are querying 1 GB of data from OLTP, you will get the result, let's say, in 1 hour. But the same data, if you query from OLAP systems, you will get the data within 15 to 20 minutes. So for high writes, organizations will use OLTP databases. For high reads, they'll use OLAP. So in this place, OLAP, you can Redshift, Snowflake, BigQuery. So these are all OLAP, SAP HANA, like, yeah, all these are comes to OLAP systems. Transaction processing like Oracle, there are like Microsoft SQL Server, all these are like OLTP. Yeah. So this is a typical on-prem architecture. So in on-prem, typically the companies will have different sources of data. So transactional processing, like relational databases. In the example I have given, like MySQL and Oracle, right? Both are relational databases, and enterprise applications. For example, if the company is using SAP for their billing, so it's application, right? The data comes from enterprise applications like Salesforce, SAP, different third-party applications, and web data log like Google Analytics, Adobe Analytics, IoT. So the data comes from different sources and in different forms. And in the ETL world, like the first step is data integration, right? We have to extract the data from all these sources. So that's where like Informatica, different ETL tools will come into picture, where we have to extract the data from all these sources. And for data transformations, we'll use like Python, Spark, again ETL tools, and we'll put the data into finally, like once the data is normalized and aggregate. Once the data normalization is done and aggregation, finally it is loaded into data warehouse. So we will do all these aggregations and all. For example, for example, Amazon sales per day they will sell like n number of items, right? If I store everything into data warehouse, the data will become huge here. So if anyone wants to connect a Power BI or like Tableau to this much, huge amount of data, those tools will crash, right? So we just interested in the number of sales. For example, if I'm doing analytics on Amazon, I'm just interested in number of products they sold, not all the details. Maybe the count of the products, maybe how many mobiles they sold, like count of mobiles, not like details. If we go into details like which model and what is the price, all this will come. Count means I'll just get one row for one day, right? But if you go into details, for example, let's say 2000 mobiles, then 2000 rows. 2000 rows, I don't load it here, just like high level number. For this reason, we'll do aggregation and normalization. If the data is coming from two different sources and we are comparing, we have to normalize the data. So finally, once the data warehouses and data marts are built, so this data analytics teams like data science teams and again reporting teams, they will connect their tools to the data warehouse, and they'll create reports. So this is like typical on-prem architecture. So here, if you see, there are like data backups organization has to take, right? If I'm using Oracle as my OLAP database, again, the admin teams, they have to take backup, and they have this mirror DBs and all. Basically, there are a lot of backups will be taken each and every day for all the databases. So it's complex and costly with multiple copies of data. Okay. So in on-prem, typically this is how uh, the process of data warehousing, like extract the data. So now cloud, what are the advantages if I have to compare like on-prem with the cloud? So what are the advantages in using the cloud data warehousing solutions like Snowflake, Redshift? All these are like cloud-based data warehouses, right? So anywhere and anytime access. For example, if you are using if it is on-prem database, it is accessed only on the company network, right? If it is like if you want to access outside, it is not possible. For example, if any vendor or like customer, especially vendors, if they want access, it is difficult. Again, you have to open the firewall, and again it's a admin process is involved to facilitate that access. It is not straightforward. So, but if it is cloud, it is easy to configure, and based upon your use case, you can access it from anywhere. So you can access from your browser, and not only from your company network, you can access it from anywhere. So affordable, the first reason is affordable. Like if comparing to on-prem, cloud is little cheap. So there is no upfront cost, especially like if I have to set up a data warehouse, what is the first thing? I have to buy the server, right? So I have to buy the server, and again, if I want to go with Oracle, I have to pay licensing fee for Oracle, and again I have to hire admins to install this Oracle. And again, in that particular server, we have to install Microsoft SQL Server or like Linux or anything. Again, that's a different thing. Again, security, all this lot of admin work, and again air conditioner, server rooms, right? It's lot of capital investment there in this process, like buying servers, paying employees, a licensing fee, and for upgrades again, like for example, if Oracle is upgrading from 16G to 17 or 18, whatever, again we need to pay separate licensing fee for that. So a lot of cost is there. But in if we move to cloud, we can avoid all this cost. There is no upfront fee. So cloud is like if you use it for 1 hour, you'll pay only for 1 hour. So in the weekend, if you are not using anything, then you don't need to pay anything. But in on-prem, the ACs and electricity, it's keep on like going. And yeah, basically based upon your previous usage, and you can actually predict the cost and all. So worry-free IT. So yeah, we don't need to worry anything about configuring and all, like security updates like patching and OS upgrades and software updates. We don't need to worry. So everything will be taken care from cloud vendor. Comparing to security also, so cloud is highly secure. So comparing to on-prem, I mean, I mean, we don't need to worry about security. It is highly secure, and it is everything is taken care from vendor perspective. Quick deployment. So, for example, yeah, few years back, if I'm like in .NET, when we are building applications, my team, when we are actually building applications, we are worried about, okay, will this application will able to scale? I mean, will the existing architecture in on-prem, will it able to support this application? For example, 1,000 users are using. Suddenly, if 2,000 new users are started using this application, will that load? I mean, the existing on-prem systems will able to handle that much traffic or not? I cannot test it, right? Because in on-prem, I have only one server. If I want to test it for 2000, like this application, one application I'm designing just for 1,000 users, but I want to test it. What if like 500 more users will access that? I want to test that scenario. I cannot test it in on-prem because again, if I have to test, they have to purchase a new server. It's a long process. But with the cloud, the deployment is very quick, and also from application development. Like for example, if I want to test in cloud, it is instantly we can the scalability is there, right? We can scale up and scale down just to meet, and for testing also we can test the various scenarios quickly. So yeah, so this is about the data warehousing, like cloud advantages, few cloud advantages. Yeah, I hope already everyone knows what is Snowflake, but I just take some of your time. Yeah, Snowflake is analytical data warehouse provided as a software as a service. So this is provided as a software SaaS model. That means if companies want to install it on-prem, that is not allowed. It is completely offered as a software as a service. So Snowflake provides a warehouse that is faster, easier to use, and far more flexible than traditional data warehouse offerings. So if you compare Snowflake with on-prem, like Oracle and Microsoft, it got like a number of features, which is like very advanced if you compare with basically like on-prem. So yeah, Snowflake is faster. If you compare with on-prem, it is faster, easier to use. So Snowflake is very simple. I mean, if you compare with Redshift and BigQuery also, Snowflake got more features than these databases, and yet it is very easier to use comparing to other databases, and also far more flexible than traditional data warehouse offerings. So as this is offered as a software as a service, whatever the points we discussed in the previous slide, like infrastructure, maintenance cost, so everything will be taken care by Snowflake. So let's see what are the high level features of this Snowflake, of this cloud-based database Snowflake. So it's a complete SQL database. So same like your on-prem, like Oracle, MySQL, Teradata, like all these databases. So Snowflake is also cloud-based database. Zero management. As this is a cloud-based, we don't need to worry about like managing this, like installing and security and all. This is for all of your data. That means not only for relational data, for both structured and semi-structured data for all of your users, and it's only pay for what we use. So the quick features of Snowflake is store all of your data in one place. So in organization, we have the data comes in different forms. Yeah, in previous slides, I already showed. For example, in my company, so we have this SAP based products, and Salesforce is there, and we have this Hadoop, and again APIs. The data comes from vendor APIs. There are like different sources, and the data comes in different forms. Here, like the data is in GBs, and some in some of what existing in Hadoop bundle, it is there in more than like TBs, or like, yeah, petabytes is there. So all this data comes in different forms and different shapes. As of now, the challenge is, before implementing Snowflake, we used to have Hadoop, but again, yeah, Hadoop is little cheaper comparing to this other databases like like SAP and Salesforce. It is cheaper, but the problem here is again maintenance. So if we are upgrading anything, like few challenges we observed, hot, yeah. So Cloudera is the vendor. Earlier they used to have Hortonworks, and after that Hortonworks acquired by Cloudera. So yeah, Cloudera is the vendor to manage. So here, like, we are around running like more than 160 clusters, I guess, 160 clusters. But the problem is again, in not everyone in the company is comfortable using this Hadoop based, right? Hive. So Hive is the one. Like, not all the teams are comfortable using this solution. So the problem is, yeah, I was working for this. I used to work for this healthcare provider. Like, see, it's one of the largest healthcare provider in US. They have literally petabytes of data every day. They'll collect like huge amount of data in the patients testing, and reports. They have like huge data comes from different applications and different testings from labs and all. So yeah, the business need is. They are scanning around like terabytes to petabytes of data every time, not a single time. Each and every day this process will be repeated. For example, if they collected like one cancer patient sample, they have to run this sample against like their previous data. There are some data science models which will predict, so what are the chances he'll develop cancer, like, what exactly. So it has to run this data point with huge data. So we tried Google BigQuery, we tried Snowflake, we tried, sorry, before Snowflake we tried this Hadoop ecosystem like Spark and all, n number of, like, almost tried each and everything. So every time we are going with vendor to vendor, the challenge is scanning this huge amount of data, and maintaining is not easy day to day. We have like more than 40 people like maintaining this only one system, but still we are not able to manage the workloads and all. So yeah, 2019, then that's where like I started with Snowflake. At that time, they don't have these many features. No time travel, no multi-cluster warehouse. But we kind of liked it because of its simplicity and easy of use. But we just did POC and kept it aside. But 2020, where like we decided to move away from this Hadoop to Snowflake. Anyway, that's the story. But yeah, the challenges here is, in any company, the main challenge is data is there in different applications in different forms. And also, if you think about the cost, we need to pay a separate licensing fee for SAP, Salesforce, Microsoft, and Oracle. Different licensing fee. That is one thing. And again, admin teams are different. Like, right, if I'm using SAP, I have to hire SAP resources from market. So there is like human, like, employees cost. So this is like second factor. Okay, I'm fine with this too. Anyway, I'm using, I have to pay. Nothing comes free. But the problem here is, for example, if my marketing database is Microsoft SQL Server, like Google Analytics, Adobe Analytics, my Facebook campaigns, digital campaigns, and all. Right, nowadays, if you see the healthcare, like, advertisements, you will see like a whole body checkup, like so and so price offer is running. So they will do a lot of advertising, right? Digital marketing in YouTube advertisements and all. For example, if for this quarter, if the company is spending 1 million on advertising, they'll get some sales, right? Definitely the sales are there in this application. If they want to do this comparison, they have to wait like 1 or 2 business days, because data is in two different applications. So it is very difficult for do this analytics because it is scattered across two different platforms. So what companies currently doing is they are implementing Snowflake as enterprise-wide data warehouse. That means all these are like individual, applications or different sources. So we are implementing Snowflake as enterprise-wide data warehouse. That means I'll extract the data from this database and I'll just dump the data into Snowflake. So uh, different sources. So in Oracle or MySQL also we can do the same thing. But how Snowflake is different from this is it support both structured data and semi-structured data. So in Hadoop we have different data formats, right? ORC, Parquet, XML, JSON. So if I have to load the JSON data into MySQL and all, I have to transform it, right? Again, like one software developer or like, someone has to use Python, Java, to extract the data from this APIs, they have to transform the data into relational format and then they have to load the data, right? Till this step is completed, the business teams may not able to do the analytics. So there is again dependency. So again, this team is dependent on this team to do this process. So again, we observed like a lot of gaps between the teams. Their understanding is different. This team understanding is different. So a lot of gaps are there. So the idea is once the Snowflake is implemented as a enterprise-wide data warehouse, we'll just extract the data from all these systems and we will dump this data into Snowflake. That means instead of like earlier the data is scattered across all these applications and databases. Now I have the data in one database where I can do analytics and all. It is easy for me to build reports. So it is easy to for me to compare all this data. Yeah, so this is about like the high level idea of how the companies are implementing Snowflake in organizations. Okay, so we can store structured data, semi-structured, everything, and per second pricing. That means in the weekends, if you are not using in your companies, still the servers will keep on running, right? Saturday and Sunday, it has to keep running. So it means electricity and again air conditioning, all this. But yeah, it's per second cloud. We don't need to worry about that. It's will pay. Yeah, we'll pay only for what you use. That means if you use it for 1 hour, you will pay only for 1 hour. So it's a complete SQL data warehouse. So if you know SQL, then that is good enough to start with Snowflake.